What if I told you that on a hot summer night in 1977, a volunteer astronomer circled 6 characters on a computer printout that might prove we're not alone in the universe? August 15th, 1977, Ohio. Jerry Ehman is doing the most boring job in science, staring at computer printouts filled with numbers and letters. He's a volunteer at Ohio State University's Big Ear radio telescope, and his task is simple: look through data from space and find anything weird. For 3 days, the giant radio dish has been listening to the cosmos. Most of what it hears is just cosmic noise, the random static of the universe. Jerry has done this hundreds of times before. It's tedious work, like searching for a single typo in a telephone book. But tonight is different. 6EQUJ5. His hand trembles as he reaches for a red pen. The sequence stands out like a beacon in the cosmic noise, a signal 30 times stronger than the background radiation, lasting exactly 72 seconds. Without thinking, Jerry circles the anomaly and scrawls a single word in the margin that will echo through history. Wow. For exactly 72 seconds on that August night, humanity may have received its first message from intelligent alien life. The signal was broadcast on the precise frequency that hydrogen, the most abundant element in the universe, naturally emits at 1420 megahertz. This was exactly what scientists had predicted an alien civilization would use as a cosmic calling card, a universal frequency that any technologically advanced species would recognize. But here's the spine-chilling part: the wow. Signal has never been detected again. Despite decades of searching with increasingly powerful telescopes, that brief cosmic whisper remains as mysterious today as it was 47 years ago. Was it a brief hello from across the galaxy, a malfunction in our equipment, or something far more mysterious, perhaps a civilization that broadcast once and then went silent forever? The wow signal represents everything tantalizing and frustrating about humanity's search for extraterrestrial intelligence. It gives us hope that we're not alone, while simultaneously demonstrating just how difficult it is to prove that other minds exist among the stars. But as we're about to discover, Jerry Ehman's red pen mark was just the beginning of humanity's most important hunt. Look up at the night sky on any clear evening. Each pinprick of light represents a star, and our Milky Way galaxy contains over 400 billion of them. Conservative estimates suggest there could be 40 billion Earth-like planets in habitable zones, places where liquid water can exist and life as we know it might flourish. The numbers are staggering. If even a tiny fraction of these worlds developed intelligent life, the galaxy should be bustling with alien civilizations. So, where is everyone? This is the Fermi paradox, named after physicist Enrico Fermi, who famously asked this question during a lunch conversation in 1950. Where are they? If the universe should be teeming with intelligent life, why do we find ourselves in what appears to be a cosmic ghost town? The silence is so profound it has a name among scientists: the Great Silence. What if they're not quiet at all? What if we're just not listening properly, or looking in the right places, or using the right methods? This possibility has driven scientists to develop increasingly sophisticated ways to eavesdrop on the cosmos. In 1960, a young astronomer named Frank Drake pointed the Green Bank radio telescope in West Virginia toward 2 nearby stars, Tau Ceti and Epsilon Eridani, and listened for artificial signals. This was Project Ozma, named after the princess in L. Frank Baum's Oz books, humanity's first systematic search for extraterrestrial intelligence. Drake found nothing during his brief survey, but he had proven something revolutionary. We possess the technology to eavesdrop on alien civilizations, if they exist and if they're broadcasting. Drake went on to formulate what became known as the Drake equation, an attempt to calculate how many communicating civilizations exist in our galaxy. The equation considers factors like the rate of star formation, the fraction of stars with planets, the number of planets that could support life, the fraction that actually develop life, the fraction that develop intelligent life, the fraction that developed technology capable of interstellar communication, and how long such civilizations survive. Depending on the values you plug into Drake's equation, the answer ranges from "we are completely alone" to "millions of alien civilizations are broadcasting right now." The uncertainty in these numbers is enormous, which is why we must search rather than simply calculate. Fast forward to today, and the search has exploded in scale and sophistication beyond anything Frank Drake could have imagined. The $100 million Breakthrough Listen initiative, founded by tech billionaire Yuri Milner and backed by the late Stephen Hawking, represents the most comprehensive alien hunt in human history. The scope is staggering. Breakthrough. Listen is monitoring 1 million nearby stars, scanning the entire galactic plane, and observing 100 nearby galaxies. The project's radio telescopes record 6 gigahertz of bandwidth, that's 6 billion different frequencies simultaneously, generating 24 gigabytes of data every second. To put that in perspective, the project generates more data in a single day than all previous SETI projects combined generated in an entire year. But here's the challenge that keeps SETI scientists awake at night. We're looking for a needle in a haystack the size of the observable universe. The parameter space for the search is mind-bogglingly vast. Aliens could be broadcasting on any of billions of possible frequencies, using any of countless possible signal types, from any direction in space, at any time. They might use radio waves or optical lasers or communication methods we haven't even invented yet. What if artificial intelligence could find patterns that human eyes would miss? This question is revolutionizing the search for extraterrestrial intelligence. In 2023, researchers at the University of Toronto developed a machine learning algorithm that discovered 8 potential alien signals that previous methods had completely overlooked. The AI analyzed data from 820 stars collected by the Green Bank telescope and found signals that bore the hallmarks of extraterrestrial technology: narrow bandwidth, unusual frequency patterns, and characteristics that distinguish them from natural cosmic phenomena. Dr. Steve Croft from Breakthrough Listen explained the fundamental challenge. The key issue with any techno-signature search is looking through this huge haystack of signals to find the needle that might be a transmission from an alien world. The vast majority of the signals detected by our telescopes originate from our own technology, GPS satellites, mobile phones, and the like. The catch with these 8 AI-discovered signals? When astronomers tried to detect them again, they had vanished, just like the "wow" signal decades earlier. This pattern of appearing and disappearing signals has become a recurring theme in SETI research, leading to both excitement and frustration in equal measure. April 2019. The Parkes Observatory in Australia, affectionately known as the Dish, was pointed at Proxima Centauri, our nearest stellar neighbor, when it detected something extraordinary. A narrowband radio signal at 982.002 MHz showed frequency shifts consistent with the movement of a planet. The signal persisted for several hours and appeared to originate from the direction of the star system that hosts Proxima b, a potentially habitable exoplanet. Breakthrough Listen. Candidate 1, or BLC-1, was born. For months, a team of scientists worked feverishly to rule out terrestrial interference. The signal seemed to tick every box for an alien transmission. It had a narrow bandwidth typical of artificial signals, showed frequency drift consistent with a planet's motion relative to Earth, and came from the nearest star system known to have potentially habitable planets. One researcher called it on par with the "wow" signal. The excitement was palpable. Here, finally, might be the confirmation that humanity had been seeking for decades. Media outlets around the world prepared stories about humanity's first contact with alien intelligence. The devastating conclusion came after exhaustive analysis published in Nature Astronomy in 2021. BLC-1 turned out to be terrestrial interference, specifically an electronically drifting intermodulation product of local, time-varying interferers. In simpler terms, it was electronic noise from human technology that happened to mimic exactly what scientists expected an alien signal to look like. The BLC-1 saga perfectly illustrates both how desperately humanity wants to find its cosmic neighbors and how careful we must be not to fool ourselves. It also demonstrates the rigorous scientific process required to verify any potential detection. In SETI research, extraordinary claims require extraordinary evidence, and the bar for proof is necessarily high. While we've been listening for alien signals, we've also been broadcasting our own messages to the stars, like cosmic messages in bottles cast into the galactic ocean. November 16, 1974. Scientists gathered at the Arecibo Observatory in Puerto Rico to celebrate the completion of a major upgrade to the world's largest radio telescope. To demonstrate the telescope's new capabilities, they decided to send humanity's first deliberate transmission to extraterrestrial intelligence. The Arecibo message, composed by Frank Drake and Carl Sagan, was a masterpiece of concise communication. The 1679-bit binary message was designed to be decoded by any intelligent species that might intercept it. When arranged in a rectangle of 23 by 73 columns, both prime numbers to indicate artificial origin, the binary code revealed a pictogram containing humanity's cosmic resume. The message included the atomic numbers of hydrogen, carbon, nitrogen, oxygen, and phosphorus, the elements that make up DNA. It showed the chemical structure of DNA itself, a stick figure of a human being with height measurements, a representation of our solar system with Earth highlighted, and a diagram of the Arecibo telescope that sent the message. The transmission was aimed at the globular star cluster M13, containing about 300,000 stars located 25,000 light-years away. The message will take 25,000 years to reach its destination, and any reply would take another 25,000 years to return to Earth. This wasn't a conversation starter, it was a demonstration of human technological achievement and a symbolic gesture of cosmic goodwill. But here's a twist that reveals humanity's deep desire to make contact. We got a reply. In 2001, a crop circle appeared in a field near the Chilbolton Radio Telescope in Hampshire, England. It was a near-perfect replica of the Arecibo message, but with intriguing differences. Silicon had replaced carbon in the DNA section, suggesting a different biochemistry. The human figure showed a large head and smaller body, like popular depictions of aliens. The solar system diagram emphasized different planets, and the representation of Arecibo was replaced by a complex pattern suggesting some kind of space-based telescope. Scientists quickly debunked this reply. The original Arecibo message won't even reach its target for another 24,000 years, making an immediate response impossible. The crop circle was almost certainly an elaborate human hoax, but it revealed something profound about human psychology, our desperate desire to know we're not alone in the universe. 124 light-years from Earth, in the constellation Leo, orbits a world that has captured the imagination of astrobiologists worldwide. K2-18b is a planet unlike anything in our solar system, 8.6 times more massive than Earth and 2.6 times wider, sitting perfectly in its red dwarf star's habitable zone where liquid water could exist. In 2023, the James Webb Space Telescope trained its powerful instruments on this distant world and made a detection that sent shockwaves through the scientific community. When K2-18b passed in front of its star, an event called a transit, Webb analyzed the tiny fraction of starlight that filtered through the planet's atmosphere. Different molecules absorb different wavelengths of light, leaving behind unique fingerprints that Webb's sensitive instruments can detect. The telescope found strong evidence for methane and carbon dioxide in K2-18b's atmosphere, gases consistent with a hydrogen-rich atmosphere overlying a liquid water ocean. But it was the potential detection of another molecule that caused the real excitement, dimethyl sulfide, or DMS. On Earth, DMS is produced exclusively by living organisms, specifically marine phytoplankton. It's one of the most abundant organic sulfur compounds in our atmosphere and has long been considered a potential biosignature, a chemical signature that could indicate biological processes on other worlds. The detection of DMS in K2-18b's atmosphere was hailed as potentially the first biosignature found on an exoplanet. Dr. Niku Madhusudan from the University of Cambridge, who led the research team, called the results astounding and suggested they could represent the first hint of an inhabited alien world. The discovery made headlines worldwide as possibly the strongest evidence yet that life exists beyond Earth. But here's where the story takes a sobering turn. What if our most promising discovery isn't what it seems? The technology behind these detections is breathtaking in its precision. Scientists can analyze the chemical composition of an alien world's atmosphere from a distance of 124 light-years using nothing but filtered starlight. When K2-18b passes in front of its star, astronomers observe a tiny dimming of the star's light, less than 0.1%. Within that minuscule signal lies information about the planet's atmospheric composition. The process is like forensic science on a cosmic scale. Webb spectrographs spread the filtered starlight into its component wavelengths, creating a spectrum that reveals which molecules are present in the planet's atmosphere. Each molecule has its own unique spectral fingerprint, allowing scientists to identify atmospheric components from impossible distances. But the interpretation of these spectral fingerprints depends heavily on assumptions about the planet's atmospheric structure, temperature, pressure, and composition. Small changes in these assumptions can dramatically alter the conclusions. This is where the K2-18b controversy begins to unravel. In 2024, independent scientists detected DMS in the tail of a comet in our own solar system, a place with absolutely no biology. This discovery shattered the assumption that DMS could only be produced by living organisms. If natural non-biological processes could create DMS in space, then its detection on K2-18b might not indicate life after all. Independent reanalysis of Webb's data yielded conflicting results. Jake Taylor from the University of Oxford used simpler analytical methods and found no evidence of DMS at all. Instead of the bumps and wiggles in the spectrum that would indicate molecular absorption, Taylor found the data is consistent with a flat line. The controversy highlighted a fundamental challenge in the search for life. The interpretation of atmospheric spectra depends on complex computer models and assumptions that might be wrong. As Laura Kreidberg from the Max Planck Institute for Astronomy noted, if we want to claim biosignatures, we need to be extremely sure. The K2-18b saga demonstrates both the promise and the peril of our current search for alien life. Even our most advanced telescope may not be powerful enough to definitively prove that life exists on other worlds. The signals are subtle, the data is noisy, and the risk of false positives is high. October 19, 2017. Robert Warwick, an astronomer at the University of Hawaii, was reviewing data from the Panoramic Survey Telescope and Rapid Response System when he spotted something unprecedented, an object moving through our solar system that had clearly come from interstellar space. Oumuamua, Hawaiian for messenger from the distant past, was the first confirmed interstellar visitor to our solar system. But this cosmic traveler was bizarre beyond anything scientists had seen before. Its elongated shape had a length-to-width ratio of at least 5:1, making it look like a cosmic cigar or needle. Most asteroids and comets are roughly spherical or have moderate elongations, but Oumuamua was stretched into an extreme configuration. Even stranger, Oumuamua showed non-gravitational acceleration as it left the solar system. Something was speeding it up beyond the pull of the sun's gravity. Comets often show similar acceleration when ice sublimates and creates a rocket-like effect, but Oumuamua showed no signs of outgassing or a visible tail. Enter Avi Loeb, chair of Harvard University's astronomy department and one of the world's most respected astrophysicists. Loeb proposed a radical explanation that would make him both famous and controversial. Oumuamua might be an alien artifact, specifically a light sail propelled by radiation pressure from stars. We have no way of knowing whether it's active technology or a spaceship that is no longer operative and is continuing to float in space, Loeb explained in interviews. But if Oumuamua was created together with a whole population of similar objects that were launched randomly, the fact that we discovered it means that its creators launched a quadrillion probes like it to every star in the Milky Way. A light sail is a form of spacecraft propulsion that uses radiation pressure from light to push ultra-thin reflective material through space. Human engineers have built small light sails and demonstrated their feasibility. An advanced alien civilization might construct massive light sails to explore the galaxy, sending them drifting between star systems like cosmic tumbleweeds. Loeb's hypothesis was met with skepticism from most of his colleagues. They proposed alternative explanations. Oumuamua could be an unusual comet whose acceleration was caused by outgassing hydrogen ice, which would be difficult to detect from Earth. Or it might be a fragment of a larger object that was shattered by tidal forces. But Loeb stood by his analysis, arguing that scientists were too quick to dismiss the possibility of alien technology. The scientific method encourages us to consider all possibilities, he said. If we rule out the extraterrestrial hypothesis a priori, we might miss the greatest discovery in human history. The debate over Oumuamua continues today. Most scientists favor natural explanations, but the object has left the solar system and is no longer observable, leaving key questions forever unanswered. Whether natural or artificial, Oumuamua has forced scientists to confront the possibility that our galaxy might be filled with wandering objects of unknown origin. If Loeb is right, and our galaxy contains quadrillions of alien artifacts drifting between the stars, then space archaeology might become humanity's next great scientific frontier. We might be surrounded by the technological remnants of alien civilizations, waiting to be discovered and studied. In July 2025, astronomers discovered 3 I/ATLAS, the third interstellar object ever detected. Once again, Avi Loeb proposed it could be alien technology, citing its unusual trajectory, size, and timing. The pattern is clear. Every time we discover something unprecedented in space, the alien hypothesis emerges. Are we seeing evidence of extraterrestrial technology? Or are we so desperate to find aliens that we're seeing them everywhere? Modern SETI has evolved far beyond Frank Drake's original concept of listening for radio signals. Today's search encompasses a vast range of potential signatures that alien civilizations might leave in the cosmos. Optical SETI searches for brief laser flashes that could serve as interstellar beacons. The Veritas collaboration uses arrays of telescopes to detect nanosecond duration light pulses that would stand out dramatically against the natural background of space. Advanced alien civilizations might use powerful lasers to communicate across vast distances, creating cosmic lighthouses visible across thousands of light years. Scientists also search for technosignatures, evidence of alien technology that doesn't require intentional communication. These might include artificial lights on the night side of exoplanets, industrial pollutants in alien atmospheres, or massive megastructures that block starlight in unusual patterns. The most famous proposed megastructure is a Dyson sphere, a hypothetical construction that surrounds a star to harvest its energy output. The search has even expanded to neutrino astronomy. Neutrinos can pass through entire planets without being absorbed, making them perfect for covert interstellar messaging. An advanced civilization might use neutrino beams to communicate while remaining undetectable to potential enemies, a concept borrowed from science fiction that's becoming scientific reality. What if aliens are clustering where we least expect them? The breakthrough. LISTEN investigation for periodic spectral signals, BLIPSS, searches for repeating artificial signals from the center of our galaxy, the region with the highest density of stars and potentially habitable planets. If a technologically advanced civilization wanted to send a signal that many other civilizations could detect, They might aim it from the galactic center outward, like a cosmic lighthouse. The galactic center is visible from most locations in the galaxy, making it an ideal place for a beacon intended to announce a civilization's existence to as many potential recipients as possible. Science fiction writer Liu Cixin proposed a chilling explanation for the Great Silence called the Dark Forest Hypothesis. In this scenario, the universe is filled with intelligent civilizations, but they remain silent because revealing yourself means death. Imagine the galaxy as a dark forest where every civilization is an armed hunter creeping through the trees. The first law of the dark forest is survival, and any civilization that reveals its location risks being destroyed by more powerful neighbors. Every civilization assumes that any other civilization it encounters will eventually become an existential threat, so the safest strategy is to destroy other civilizations before they can grow powerful enough to pose a danger. In this dark forest universe, the galaxy is silent not because it's empty, but because everyone is hiding. Any civilization foolish enough to broadcast its location is quickly eliminated by older, more established powers. This could explain both the Fermi paradox and why SETI searches have found nothing but cosmic silence. Could this terrifying scenario be reality? If so, humanity's radio and television broadcasts have been announcing our location to the galaxy for over a century, potentially painting a target on our planetary home. The SETI community has established detailed protocols for what happens when we detect a genuine alien signal. These protocols, developed over decades of careful consideration, reflect both the magnitude of such a discovery and the need for verification before announcement. When a potential signal is detected, the first step is verification. The signal must be independently confirmed by multiple observatories to rule out equipment malfunctions, terrestrial interference, or natural phenomena. This process can take weeks or months, during which the discovery remains secret to prevent false alarms. Next comes detailed analysis of the signal's properties. Scientists study its frequency, modulation, direction of origin, and any embedded information. They look for characteristics that distinguish artificial signals from natural cosmic phenomena. Once verified, the discovery goes through peer review, where independent scientists examine the evidence and methodology. Only after this rigorous process would an announcement be made to the International Astronomical Union, world governments, and the public. Scientists use the Rio scale to rank the significance of potential SETI detections, similar to how the Richter scale measures earthquakes. The scale ranges from 0, insignificant, to 10, extraordinary, genuine alien contact. The WOW signal ranks about a 6, while BLC-1 reached 4 to 5. Humanity is still waiting for a 10. How close are we to the greatest discovery in human history? Based on current technology and search methods, the timeline for contact looks increasingly promising. The Vera Rubin Observatory, which will begin operations soon, will discover thousands of asteroids and potential interstellar objects, giving us many more chances to spot alien artifacts like Oumuamua. The extremely large telescope with its 39-meter mirror will be capable of directly imaging Earth-like planets around nearby stars and analyzing their atmospheres for biosignatures with unprecedented precision. The square-kilometer array, currently under construction, will be 50 times more sensitive than current radio telescopes, allowing us to detect weaker signals from more distant civilizations. Machine learning algorithms are being trained to recognize patterns that human scientists might miss, potentially uncovering alien signals hidden in decades of archived data. Leading scientists are cautiously optimistic about the prospects for discovery. Sarah Seeger at MIT estimates a 50% chance within 20 years based on atmospheric biosignature studies. Jill Tarter from the SETI Institute emphasizes that we've barely begun to search, given the vast scale of space. Avi Loeb suggests that evidence may already exist in data we haven't properly analyzed, but even as our technology improves and our searches intensify, we must confront a disturbing possibility. What if the reason we haven't found aliens isn't because they don't exist, but because something destroys intelligent civilizations before they can spread across the galaxy. This hypothetical obstacle is called the Great Filter, a catastrophic event or a series of events that prevents most life from evolving into spacefaring civilizations. Possible great filters include nuclear self-destruction, climate change, artificial intelligence gone rogue, asteroid impacts, gamma-ray bursts, or simple resource depletion. The terrifying question is whether the great filter lies behind us or ahead of us. If it's behind us, if the evolution of intelligence itself is the rare event, then we might be among the few species lucky enough to develop technology. But if the great filter lies ahead of us, then our own civilization might be doomed to the same fate that has apparently befallen countless others. Recent developments have added new chapters to the WOW signal mystery. In August 2024, scientists at the University of Puerto Rico announced they may have finally solved the 47-year-old puzzle. Using data from the Arecibo Observatory collected before its collapse in 2020, they found similar but weaker signals coming from cold hydrogen clouds in space. Their hypothesis suggests the WOW signal was created when a magnetar, a hyperdense star with an incredibly powerful magnetic field, blasted a hydrogen cloud with intense radiation, causing it to briefly glow like a cosmic laser at the exact frequency of a hydrogen emission. The evidence includes multiple similar signals detected at the expected frequency, signals that originated from regions known to contain cold hydrogen gas, and a theoretical mechanism that could explain both the signal's intensity and its brief duration. However, not all scientists are convinced. SETI astronomer Jason Wright noted, "He's suggesting a phenomenon that has never been observed. The set of physical conditions is extremely delicate and specific, and it's not clear if that's even possible." Even if this natural explanation is correct, it doesn't diminish the WOW signal's importance to the search for extraterrestrial intelligence. As Wright observed, the false positives of SETI can lead to amazing science. When astronomers first discovered pulsars in 1967, they initially called them LGM for little green men, before realizing they were natural phenomena, and the discovery still earned a Nobel Prize. The collapse of the Arecibo Observatory in December 2020 symbolized both loss and transition in the search for extraterrestrial intelligence. For 57 years, this massive radio telescope had been humanity's most powerful ear to the cosmos, detecting the first exoplanets, sending the first deliberate message to aliens, and conducting the longest-running SETI survey in history. But the search continues with new and even more powerful tools. The FAST telescope in China, the Allen Telescope Array in California, the Meerkat Array in South Africa, and the upcoming Square Kilometer Array represent humanity's unwavering commitment to answering the ultimate question, are we alone? As we stand on the threshold of potentially the greatest discovery in human history, we must consider the profound implications of contact. Carl Sagan, who spent his life searching for extraterrestrial intelligence, believed that confirming alien existence would be the most significant event in human history. The discovery would transform human civilization in ways we can barely imagine. It would affect religion, as faiths grapple with the existence of other intelligent beings in God's universe. It would reshape geopolitics, potentially uniting humanity against a common other or creating competition between nations to establish contact first. It would accelerate technological development, as even detecting a simple radio signal would prove that interstellar communication is possible. Perhaps most importantly, it would change human psychology and our sense of purpose in the universe. Knowing we're not alone would be simultaneously humbling and inspiring. Humbling because we would no longer be the universe's only intelligent observers, but inspiring because it would prove that intelligence and consciousness can arise repeatedly in the cosmos. Today, at this very moment, radio telescopes around the world scan the skies for artificial signals. Space telescopes analyze alien atmospheres for signs of life. AI algorithms process cosmic data looking for hidden patterns. Scientists dedicate their lives to answering humanity's most profound question, The next great discovery could happen tomorrow, next year, or next decade. A computer algorithm might flag an unusual signal for human review. A scientist might notice something extraordinary in spectroscopic data from an exoplanet. An interstellar object might display characteristics that can only be explained by artificial origin. Whether we find them or not, the search itself has already changed us, pushing the boundaries of technology, international cooperation, and human imagination. We have become a species that actively seeks its place in the cosmic community, that listens to the stars and dreams of contact with other minds. The hunt for ET isn't just about finding aliens, it's about understanding our place in the cosmos and discovering who we are as a species. We are living in the most exciting time in the history of the search for extraterrestrial intelligence, surrounded by new technologies and expanding our search methods every year. Perhaps the most profound realization is that we are the universe's way of knowing itself, as Carl Sagan once said. Through our telescopes and our searches, the cosmos awakens to its own existence and possibilities. Whether we find alien intelligence or not, we have already achieved something remarkable. We have become a civilization that asks the biggest questions and has the tools to seek answers among the stars. The next chapter of this cosmic detective story could be written tomorrow. Somewhere in the world, a radio telescope will detect an anomalous signal. A computer algorithm will flag it for human review. A scientist will notice something unusual in the data, reach for a pen, and perhaps write their own version of Jerry Ehman's famous "Wow," and humanity's greatest adventure will begin. Until that moment comes, we keep listening, keep searching, and keep hoping. Because in a universe of 400 billion stars, the greatest discovery in human history might be just one signal away.